All right, guys. So today, what we are learning about, and again, you can hit the light if you need to. Today, what we're going to be learning about are absolute value functions, specifically how to solve absolute value equations as well as inequalities. So, depending on how much we get through today, we're most likely just going to do equations today and then inequalities tomorrow. Now, I've mapped out the rest of this unit, so I'm looking at your test to be next Tuesday. All right, so Tuesday the 11th, I believe. So we'll do 6.4 today and tomorrow, 6.5 Thursday, 6.6 Friday, review Monday, test Tuesday. So that also means that any classwork, Delta Math, etc., will be due by midnight on next Tuesday. All right. So if you have any makeup work, that's when it'll be due next Tuesday. Yes, ma'am.
Next Tuesday, the blitz starts basically.
Okay, so we'll figure it out there once I get more information. So we'll figure it out from there. All right. So also, I'm starting to screen record lessons and I'll upload them as well in your notes. So if you ever need those, starting today, I'm going to start doing that. So it'll basically just be the notes and I'll post them in the notes section of Canvas. All right, just be a YouTube video, basically just what we already went over in class. So if you're ever absent, that might be something to watch. If not, or if you miss something in class, that'll be something to watch too. If like just looking at the notes doesn't help you. All right. So that being said, we're starting absolute value equations today. So far with functions, we've talked about the operations, the transformations, the inverses, and now we're kind of getting into the land of specific functions. So absolute value you've probably heard of. You may have messed around with it a little bit in your past 2 math classes, but you probably haven't seen it in terms of actually solving the equations. Vanessa, can you hit that light while you're over there? Thank you. So that's what we're going to start with today. So we're first just going to start by considering this absolute value equation. So the absolute value of x is equal to 11. Now, does anyone remember what an absolute value does to a number? So for example, what is the absolute value of 2 equal to? So if you just took the absolute value of 2, what's it equal to? 2. What about if you took the absolute value of negative 2? What is it? Positive 2. So essentially, all the absolute value, if you take the absolute value of something, all it does is make it positive, regardless of if it was originally positive or negative. So in other words, if we were to solve that highlighted equation, what values of x could possibly solve that equation? What values of x could work? Negative 11 and positive 11. Because again, if you take the absolute value of a number, it makes it positive, regardless of if it's positive already or if it isn't, or if it is a negative number. All right. Now, based off of that, how do you think I would set this up to solve B? So different equation here. So this is our new equation. The absolute value of x minus 5 is equal to 11. What do you think I'm going to do? So let's think about it. What 2 answers could I get? Not for x specifically, but in general. Yes. So not so much for x, but in other words, like we want x minus 5 to equal what 2 numbers? So if we remove the absolute value signs and we just had x minus 5 equals, what 2 numbers could that expression equal so that when you take the absolute value of that expression, it'll give you positive 11? What's one number that would work? 11. And then x minus 5, what's the other number that it could be? Negative 11. So in other words, you take whatever it's equal to and separate it into the expression without the absolute value sign equal to the positive number and then equal to the negative number. And then you solve. So for these, you would just add 5 to both sides. So for both of them, we get x is equal to 16 and x is equal to negative 6. All right. So these are our two x values that work. And again, the reason we take whatever we want our absolute value to equal to, the reason we take it as a positive and negative is because as long as we get the number that they want within the absolute value symbols, regardless of if it's positive or negative, it will still give us a positive number. Does that make sense? All right. Now, always keep in mind that if absolute value of a quantity is a positive number, so if you have an absolute value expression, it has to equal a positive number. What would happen? So if the quantity has to equal a positive number, that means the quantity inside the absolute value has to be either equal to the number itself or its negative. So the original positive number or the negative of said number. All right. So what about example A? How would I set this up? So we got to break this up into two equations. So what's my first equation if I break it up? So I'll give you a hint. Both of them start with 2x minus 1. We're just taking the absolute value signs away. Now, what's one of them going to be equal to? 7. What's the other one going to be equal to? Negative 7. So that's how you break it apart. You want to get rid of the absolute value symbol by breaking it up into two different equations. One that's equal to the number that we want, and one that's equal to the negative of that number. And then you'll just solve it like you normally solve an equation. So we add 1 for both of them to both sides. Goes away. 2x equal to 8. 2x equal to negative 6. Divide both sides by 2. Goes away. Goes away. X can be equal to 4, or x can be equal to negative 3. Now, we typically write our answers as a solution set. So remember, that's when you use what I like to affectionately refer to as the squiggle bracket. And you just write negative 3, comma 4. And it doesn't really matter what order you write them in. I just automatically write things in numerical order. You don't have to. If you put 4, comma negative 3, I'd take that. So this would be our answer. So that's not a point, it's a set. We're saying that x can equal the set. It can either equal negative 3 or 4. That's how you read that. So that's why we use the squiggle bracket. I just affectionately call it the squiggle. There's a proper name for that bracket, but I don't know it. I feel like squiggle is a good defining. Y'all know what that means. All right. What about exercise B? So I got to separate the two equations first. What would one of my equations be? Landon. X plus 8 over 3 equals 10. What's the other one? Someone else. X plus 8 over 3 equals what? Negative 10. So again, we're essentially writing the equation that's within the absolute value twice. We just got to set it equal to its positive and negative. All right, and then we can solve. So I got to get rid of the fraction first. So I'm going to multiply both sides of both equations by 3. These go away. X plus 8 is equal to 30. X plus 8 is equal to negative 30. Then we subtract 8 from both sides. This goes away for both of them. X can equal 22, or X can equal negative 38. So our answer is X can equal the set of negative 38 and 22. Those are the two values that work. Now, we're not necessarily there yet, but my suggestion to you is get into the habit of double checking your answers and making sure that they work. All right, so make sure that if you plug those numbers back in for X, like just take the extra minute, even if it's just quickly putting in your calculator, just make sure that if you plug either one of those numbers in for X, you will get either 10 or negative 10. Because if you do, as soon as you take the absolute value of it, you'll get positive 10. So if you ever have it down your mind, you're like, oh, I probably didn't do that right, just take the extra minute, plug those values into your calculator back into the original equation, and see if it gets what you're supposed to get. Yes, ma'am.
I thought it's two negatives make positive.
What are you talking about?
Like negative 30 and negative 8. I thought
So
that
we're
would make a positive.
we're subtracting the 8 from a negative 30. So when you subtract, so this is the same thing as negative 30 minus 8. So this is the same thing as negative 30 plus negative 8. So that's where that comes from. So two negatives make a positive only when you're multiplying or dividing those two negatives. All right, now, sometimes your absolute value equations, the expressions are not all within the absolute value, or they're not isolated. So the absolute value is not isolated. And you got to do some algebraic manipulations to get it into this form. So what I tell my kids when they do this is, do not separate into two equations until the absolute value symbol is by itself. So what I mean by that is, if the absolute value symbol and whatever expressions within it is not by itself, meaning that there's numbers being multiplied to it outside of it, or subtracted or added to it outside of it, do not separate into two equations until after you move those other numbers. So all you should have is the absolute value brackets. All right, and you'll see what I mean in just a second. So look at example A. So our absolute value brackets are right here. So they're right here. Our goal first is to get those brackets by itself. It's almost like we're solving for X back when you did a lot of solving equations in Math 1. All right. We cannot separate into the two equations until we get rid of those numbers that are outside of the absolute value symbol. If they're inside the absolute value symbol, leave them. But if they're outside, you got to get rid of them first. So what do you think I would move first? So just pretend like the absolute value symbol doesn't exist and it's just a two-step equation. What would you do first? We would add the 7 to both sides. So I would get 5 absolute value of X is equal to 40. Then what would I do? Divide by 5. Why are we dividing by 5? What operation is the 5 happening to the absolute value of X? They're being multiplied together, so the opposite would be dividing. So we're going to divide both sides by 5. So I get the absolute value of X is equal to 8. Now I can separate the two. So once you get down to where the symbol is the only thing on one side of the equation, there's nothing outside of it. Now, if there's still like a plus something within the symbol, that's fine. But there shouldn't be anything added, subtracted, multiplied, or divided outside of the symbol. All right. Now we can separate into our two equations. So x can equal what? What are my two answers? 8 and negative 8. All right, we didn't really have to do any more solving past that. So x can equal the set of negative 8 and 8. So again, move everything outside of the absolute value symbol first, then separate it into your two equations, with one of them being positive and one of them being negative. So let's try another one, which is a little bit more complicated. So look at letter B. The absolute value symbol that we're trying to isolate is right here. All right, we're trying to isolate that expression right there because it's within the absolute value symbol. So what's the first thing I need to move? We need to add the 1 to both sides. So this goes away. I get the absolute value of x plus 3 all over 7 is equal to 9. Then what do I do? So I'm still trying to isolate this absolute value symbol. Multiply both sides by 7. So this 7 goes away. I get the absolute value of x plus 3 is equal to 63. Now, since the absolute value symbol is isolated, so there's nothing else on the outside of it, we can now separate into our two equations. So someone raise their hand, tell me what one of the equations will be. Josh. Right. So x plus 3 equals 63 is one of them. Someone else raise their hand, tell me the other one. Tomas. X plus 3 equals negative 63. So then I'm going to solve those two little equations separately, which all you got to do for both of them is subtract the 3 to both sides. So this goes away. I get x is equal to 60 and x is equal to negative 66. So I get x is equal to negative 66, or the set of negative 66 and 60. So again, you don't have to always write in set builder notation. Just get into the habit of it because it just kind of makes it easier to see where your answer is. But if you leave it like this, I'm fine with that too. It's not going to bother me. As long as I can accurately see where your answers are. All right. Now, there's also some special cases when it comes to absolute value equations. So just like any other equations, there are possibilities where they may not have solutions. So before we even go forward, I want you guys to think about this carefully. The absolute value of a number will never equal a what? What do you think the absolute value of a number will never equal? No can equal a fraction. A negative number. Why can it not equal a negative? So if I took the absolute value of negative 2, why would it not equal negative 2? Because absolute value always makes numbers positive. So it is impossible for your absolute value to equal a negative number off the bat. Now, when we separate our equations, that's different. All right? But if it's saying the absolute value of some expression is equal to a negative number and the absolute value is isolated, it's automatically no solution. It just doesn't happen. So, for example, this equation right here. The absolute value symbol is already isolated. There's nothing outside of it, but it's equal to -2. Most of you will probably try and break it apart and say -2 and 2. However, why can I not do that? So let's just try it out, see what happens. So letter A, it's asking us to show that x equals 5 is not a solution to the equation. Because if we solved this equation, we would get 5 as an answer for x. All right, so if we solved it like we've been doing, we would get 5 as an answer for x. However, let's see why it's not. Well, if I plug in 5 back into the original, and we want it to equal -2. 5 minus 7 is -2. Now, what's the absolute value of -2? +2. So is it true that +2 is equal to -2? No. So it's just not a true statement. So that's the difference. When we separate the two equations, we're saying that this number will give us the negative or positive number on the inside of the absolute value. Whereas this number will come from after we take the absolute value. So that's after we take the absolute value. So we would say like the absolute value of -2 is -2, which is not true. So if your absolute value symbol is isolated and it's still equal to a negative number, your answer automatically is no solution. All right, so for this one, this equation has no solution. And again, because, yes. And again, it's because our absolute value symbol is isolated and equal a negative number, which we know to be impossible. Because again, there's no way that if you took the absolute value of any number, positive or negative, that it will ever equal a negative number. That's just not how absolute value works. Any questions on how you would get no solution? So another thing to note is, for example, on the test that I gave my students from last semester, they had a question just like this, and a lot of them immediately went into separating and solving. When all they had to do was notice that there was a negative number, it was set equal to a negative number, and it was automatically no solution. Yes, ma'am? Which would be. Is this why I'm not an English teacher, guys? Which be impossible. I mean, I went to ECU, so it makes sense. So, those are those types of absolute values. Now, let's look at some more complex ones. So first things first, we're just going to do this graphically. Remember, you got access to Desmos. So we're just going to do these graphically. Now, let's just generate some tables from our calculator and to get these two equations. So if you're using Desmos, which I would use Desmos for absolute value because it's a bit more user-friendly. So if we're using Desmos, all right, I'm going to put in both equations on both sides. So I'll plug in, and I'll make this bigger for you guys to see. I'll plug in the absolute value of, what is it, x plus 1 or x minus 1? X minus 1. And then, what was that linear function on the other side of the equals? 2x minus 5. All right. Now, you may have to zoom in a little bit. Whoa, don't know what you did there. But So you might have to zoom in a little bit, but you're looking for points of intersection. Remember, when you're finding a solution, the point of intersection of the two graphs is where your solution would be. So if I'm looking at a point of intersection, what value do you think I'm going to use, the x or the y? So when we solve, what are we typically solving for? So if we solved an equation, what would we solve for? We'd solve for x, right? Right. So if we solve this for x and it doesn't look like it intersects anywhere else, we would use the x value of the point, which is 4. So their point of intersection is at 4, 3. All right. Now, the x coordinate specifically is what we're looking at. All right. So we want to show that the x coordinate from B is the solution to the original equation and why that would make sense. So why do you think that would make sense? So first off, how do I check to see if x equals 4 is a solution? What would I do? Maddie. Right, plug it back into both equations for x, see if you get the same y value. If you do, it's a solution. If you don't, it's not a solution. So I'm going to plug it back into both equations. So before we even solve the equation, what do you think the y value is going to be? So before we even evaluate these equations, what do you think both y values are going to equal? 3. Why do you think 3? It's the y value of the point of intersection. So I got y equals the absolute value of 4 minus 1, and y equals 2 times 4 minus 5. So this would be y equals the absolute value of 3. Y equals 8 minus 5. So y would equal 3. Y would equal 3. So yes, it works. And again, it makes sense because recall back to Math 1 when you were solving systems of equations. The point of intersection, or where they cross, is where both of those equations are equal to each other at that one point. So the x value would be the value of x that would make both of those equations equal to each other. So what I tell kids is that on the EOC, if you ever see any type of equation like this, whether it's absolute value or even equations that are not necessarily absolute value, they can be any type of equations. But if they look complicated, plug in both sides of the equation into separate parts of Desmos, find their points of intersection, you got your answer. All right, that's a really good strategy to use on the EOC. Do exactly what we did in Desmos here. Just plug in both sides of the equal sign into Desmos, find that point or points of intersection. And it can work for a regular equation too. So let's say I wanted to solve for when the equation was equal to 1. So like, let's say I wanted to know for the black one when y is equal to 1. Same thing, you would just find the point of intersection. So x has to equal 3 for 2x minus 5 by 1, y equal to 1. So that's just a little trick that you can always use. All right. So take a second and use Desmos or your calculator. Do you guys want to learn how to do it on your calculator too, or do you prefer Desmos? Because I can show you both ways. What do you guys prefer? Well, yeah, when it comes to graphing, Desmos is a lot more user-friendly, and you'll get to use Desmos on the test. So take a minute, take out your laptops, log on to Desmos very quickly, solve that equation using Desmos. So just take a quick second and just solve that equation. And remember, there may be more than one solution. So I'll give you guys about 2 minutes. Yes, sir. So if you hit the key, you see it's So guys, make sure you zoom out too, because you may have more than one answer, but your Zoom doesn't show it to you. I'll give you guys another minute, and then we'll talk about it. All right, so you should have gotten your answer by now, because all you had to do was graph the two and find the points of intersection. So, did you guys get -3 and 11 equal to x? So x equals -3, x equals 11. Did you guys get that? So, if we're looking at the graph, I graphed both sides of the equal sign separately. All right, so I have absolute value of 2x minus 1. That's my black graph, or the one that looks like a V. And then x plus 10, that's the blue graph, so the one that's a straight line. You find the 2 points of intersection. You click on them because Desmos will tell you exactly what those points are. And you only want to use the x values only. So the x values are your answers. So -3 and +11. That's how you would find that. Any questions? So remember, graph both sides of the equal signs. So graph both of these. So graph separately. So graph those two sides of the equation separately. Find the points of intersection. And then use the x values of those points as answer. So that's how you solve those. Now, you could solve those by hand, but it's a lot more complicated. We're not going to get into that. As long as you can put it in Desmos, I'm happy. All right, so once you finish writing that down, we're going to do inequalities tomorrow. But before we wrap up for today, I want to fill out a little bit of this graphic organizer. So take out that green sheet that I had you guys grab from the front of the room and look at the front side of it. So the side with the holes punched on the left. So if you didn't grab it, it's still on the front table. Now, to graph this, all right, we're just going to do a little bit of this and we'll pick it up more tomorrow, but we're only going to focus on the equation side of it. We're going to pick up the inequality side of it tomorrow. All right. Now, basically what this graphic organizer is explaining is that whenever you forget how to solve an equation, especially if it's not like a simple one that you learned back in Math 1, Desmos is your friend. Desmos can solve equations for you because remember, this EOC is calculator active. All right, it's completely calculator active. You have complete access to Desmos, and most of the answers are multiple choice, and they're not checking for showed work. Now, will I check for showed work? Yes, but because some short answers, I will have you guys do some work on it. But, if you're taking the exam, this is an easy shortcut if you just completely blank on how to solve it. So we're going to graph these two equations separately. And we're not going to do it in Desmos. We're going to actually do it on the graph. So we're going to graph it by hand. Now, if y equals 5, what type of line is that? It's a horizontal line where y is equal to 5. So that's very easy. That line would be right here. If I could draw a straight line. So, for me, the purple, yes, ma'am. Yeah. So the purple line for me is the y equals 5. Now, for the 2x minus, absolute value of 2x minus 3, we're going to make a very quick table. All right. So that means we're plugging it into 2x minus 3. And to be honest, for time's sake, we're just going to get the table from Desmos. So I'm going to put this equation in real quick. So y equals the absolute value of 2x minus 3. And I put 2 equals in there so it won't generate. There we go. Now, who remembers how to make a table to generate values in Desmos? Landon. Right, you click the gear key and then hit the little table symbol and you get a nice table. So it already gives us a good chunk of our values. So can someone just start reading the values off to me if they already got it pulled up? So when x is -2, what's the y value? Just start reading them. 7, -1, 0, So 1 is 1, and then 2 is what? They're both 1? You sure? Oh, yeah, I guess the vertex would be lower. All right, now click and type in the remaining x values. So if you click the one underneath the box underneath the 2 below the table, you should be able to insert your own x values and it gives you the y values. So in other words, if I wanted to find when x is 3, I would click the little box below in the x column, type in 3, it generates my x value, or my y value, sorry. So this should be 3, 5, 7. And can someone figure out what 6 is for me? 9. Because that's 9, I'm assuming negative 3 is also 9. Is that right? Yeah. All right, so we're going to make a very quick table. Now, I also want to grab the vertex of the absolute value from the graph, which is probably not a pretty vertex. It's 1.50. So that's like the very bottom of that graph. So I'm going to do 1.50 as the vertex of the graph, and then I'm going to graph my other points. So take a minute and just graph those other points. All right, and then you're going to draw your graph. Now remember, don't put a curve to the absolute value graph. It literally looks like a V, so it just looks like 2 connected straight lines. So don't put a curve in it because then that would make it a parabola. You want absolute value, so it looks like a V. So where are my points of intersection once you graph that? What points? So negative 1, 5, and what's the other one? And 4, 5. So what do you think the answer to my equation would be for 2x minus 3 is equal to 5? Landon. Right. We're assuming that this would be x is equal to the set of negative 1 and 4. Now, to check ourselves, we're going to do it the way that we did it by hand previously. So the absolute value symbol separated. So I'm going to go right into breaking my two equations apart. So I'd have 2x minus 3 is equal to 5. 2x minus 3 is equal to negative 5. Add the 3 to both sides, and I'm just going to do this quickly. 8. 2x is equal to negative 2. Yep. And then divide both sides by 2. X is equal to 4. X is equal to negative 1, which is exactly what we wanted. So again, if you forget how to solve absolute value equations or inequalities, especially on the EOC, because remember, this is one of the first things we'll do. You don't take your EOC to the end of the semester. Put it in Desmos. Desmos is your friend on this EOC. And to be honest, I don't care because I know that you guys probably aren't the best at math, and that's okay. I still want you to pass this class, and I want you to pass that EOC. So if you are proficient at using Desmos, you can pass that exam if you know how to use Desmos. All right, easily. All right, for example, my kids from last semester, not the best at math, but most of them passed that EOC because I taught them how to utilize Desmos to their advantage. All right. All right, any questions on that? All right, so we're going to stop there today. So there's no new Delta math. I'm not going to assign you one until possibly tomorrow. But for the packet work, I want you guys to do the rest of the equation parts. So I believe it's page 20 and 21. Correct me if I'm wrong. Pages 20 and 21 it should start with saying absolute value equations homework at the top. But that's the packet work for you guys. And I'll also go ahead and post the exit ticket. Yes, sir.